Good morning, students. Today we are going to start with LED or OLED displays. An organic light emitting diode, OLED or organic light emitting diode, also known as organic electroluminescent diode. OLED is a light emitting diode in which the emissive electroluminescent layer is a film of organic compound that emits light in response to an electric current. We know that a TV is evolved as initially during 1940 there were CRT tubes, then there were plasma CRT. After that LCD screens has been came into market, which were very thin, enough to mount on a wall and displays light enough to build into portable gadgets like cell phones. But displays made with OLED technology are even better. They are super light, almost paper thin, theoretically flexible enough to print onto clothing, and they produce a brighter and more colorful picture. What are they and how do they work? Let us take a closer look. LEDs on an electronic instrument panel are tiny colored indicator lights you see on electronic instrument panels. They are much smaller, more energy efficient and more reliable than old style incandescent lamps. Instead of making light by heating a wire filament till it glows white hot, they give off light when electrons zap through specially treated doped solid materials from which they are made. So when current passes through the PN junction of the light emitting diodes, electrons falls from conduction band to valence band, and while falling from conduction band to valence band it emits light. That light emission is a principle of LED. An OLED is simply an light emitting diode where the light is produced by organic molecules. When we talk about organic things, these days they are usually referring to food and clothing produced in an environmentally friendly way without the use of pesticides. But when it comes to the chemistry of how molecules are made, the word has a completely different meaning. Organic molecules are simply ones based on around lines or rings of carbon atoms, including such common things as sugar, gasoline, alcohol, wood, and plastic. Normal LED helps how it works. So here is we understand how normal LED works. A PN junction diode is supplied with a battery. I am telling you the working of LED first, which is very similar to OLED working. Since the working is very similar, we will explain what is LED working. An LED consists of two slabs of semiconductor materials, one of which is slightly rich in electrons or is slightly more negative charged, while the other is rich in protons, that is p-type material. When we join these two slabs together, we get an electrically neutral area at their junction, where express electrons and protons jump over to the other side and cancel each other out. However, when you connect these two slabs using electrical contacts and pass an electrical current through them, surplus electrons from the n-type slab flows and release photons from the p-type slab, which emits light. OLEDs work on the same principle, but they use organic molecules in lieu of n-type and p-type semiconductor materials to release holes and electrons. Now we will switch to OLED parts as shown in a figure. A typical OLED consists of normally 5 layers as given in figure. A cathode, then emissive layer, emission of radiation, conductive layer, and anode. When the power is switched on, the cathode starts receiving electrons from the power source and the anode starts losing them. As a result of this, the emissive layer, which is adjacent to cathode, starts becoming more negatively charged, and the conductive layer becomes more positively charged. Since positive charge particles are more mobile than electrons, they cross over to the emissive layer. Every time holes bump into electrons, quick bursts of energy are released in the form of photons, and lo and behold, light is produced. Holes keep bumping into electrons and producing light in the process as long as the power is on. That means they get energy, and electrons travel from valence band to conduction band. During this traveling, they emit energy or they radiate energy, and that energy is in the form of a light. The moment you pull the plug on the power supply, the transfer stops instantly and the screen goes dark. Let us understand advantages of OLED. First advantage of OLED is lower cost in the future. Second advantage is lightweight and flexible plastic substrate. OLED displays can be fabricated on flexible plastic substrate, leading to the possible fabrication of flexible organic light emitting diodes for further application, such as roll-up displays embedded in fabrics or clothing. If a substrate like polyethylene terephthalate can be used, the displays may be produced inexpensively. Furthermore, plastic substrates are shatter resistant, unlike the glass display used in LCD devices. Third disadvantage of OLED displays are better picture quality. OLEDs enable a greater constant ratio, better contrast ratio, and wider viewing angle compared to LCDs. Because OLED pixels emit light directly. This also provides a deeper, since a black OLED display emits no light. Furthermore, OLED pixel colors appear correct and unshifted even as the viewing angle approaches 90 degree. Fourth advantage is better power efficiency and thickness. OLED allowing a small fraction of light passing through it. Thus, they cannot show the true black. However, an inactive OLED element does not produce light or consumer power, allowing true blacks. Removing the backlight also makes OLEDs lighter because some substrates are not needed. Response time. OLED has very high OLED response time. It is as high as 240 Hz. OLED response time are up to 1000 times faster than LCD, putting conservative estimates at under 10 microseconds, which could theoretically accommodate refresh frequencies approach 100 kHz. Disadvantage of OLED: light emitting polymer LEP display showing partial failure. An old OLED display showing wear lifespan. The biggest technical problem for OLEDs is the limited lifetime of organic material. We will see plasma display in the next lecture. Thank you.